In a neuron, a nerve impulse is started by a stimulus, and when the action potential is reached, an impulse is sent through the voltage-gated channels in the plasma membrane to the neuron. The electrical impulse that was sent down through the membrane opens voltage-gated channels in the neuron. When the neuron is not being used, there's a separation of charges from the inside to the outside of the cell. The difference in charges is determined by the distribution of potassium and sodium ions inside and outside of the cell. This distribution is maintained by the sodium-potassium pump, which brings in potassium ions and pumps out sodium ions. Sodium ions are not easily able to replace their lost charges, but through particular channels, potassium ions are. Because of this, the overall charge of the inside of the cell is negative, and the overall charge of the outside of the cell is positive. The separation of charges is referred to as the resting potential of the membrane. Nerve impulses start with a stimulus. They disturb the plasma membrane and cause sodium channels to open. Sodium ions diffuse into the cell. If the stimulus is strong enough, it will cause voltage-gated sodium channels to open. The opening of the voltage-gated channels allows for sodium ions to go into the cell. This causes the inside of the cell to become less negative than the outside of the cell, which is called depolarization. The action potential when the sodium channels open up and move depolarization along the membrane. To restore membrane potential, the voltage-gated sodium channels close while the voltage-gated potassium channels open. When the voltage-gated potassium channels open, the potassium ions flow out of the cell. This allows for repolarization, which is when the inside of the cell is more negative than the outside of the cell. The sodium-potassium pump is used to balance the concentrations of sodium and potassium inside and outside of the cell. This restores the resting membrane potential.